Hi, hello everyone. Thanks for being here. Thanks for Media Evolution team for having me here. Today I want to talk about how we might use data to rewild us human beings. Let me start the talk with a bit of a controversial reflection. I want to acknowledge that climate change is hard to sense with human bodies. For example, think about a melting glacier. A glacier literally melts at a glacial pace. I calculated the speed, that's what I do for fun. And it's quite very slow for our human eyes to sense or witness actual glacier melting. So this is partly because climate change happens at a pace or scale that exceeds our sensory perception. But being able to sense something is far more important than we can imagine, because once you sense something, you know what's happening, and then that informs what kind of actions we want to take. So we all want to take an action towards climate change, or against, I'm sorry. But then we need to be able to sense climate change. And hopefully, we figured something out. We started to sense the world through data. So we might not be able to see a glacier literally melting with our bare eyes, but what we can do is to compare the data of the size of Arctic ice, and then we understand, oh, the Arctic ice has significantly decreased over 30 years. Another example, satellite imagery allowed us to observe deforestation from the sky above, and we all cannot fly. And we obviously cannot see infrared, but by using digital sensors, we can observe which trees are stressed in infrared. And this is something I want to focus in this talk, digital twin simulation. By building a digital twin of a forest and by running a simulation, we kind of sense what might happen in the future. So I want to question in this talk, what if we use digital twin simulation to rewild the way we sense the forest? But before we go deeper, I want to give you a really quick crash course on how digital twin simulation works. Of course, there are a range of diverse techniques, but in case you're wondering, I'm talking about agent-based modeling. It's really simple if you think about a SimCity. So in a SimCity, there are scenes, right? And each scenes have their own stats, like properties. So in digital forest, there is a tree agent, and each tree agent has a properties that defines what a tree is. So for example, species, latitude, longitude, how tall it is, how big their crown is, what conditions they are. And they also have their set of rules that's of their behaviors. So for example, if the sunny days continue like 10 days, tree's height will decrease 5 centimeters. By defining these agents and their rules, what we can do is feed the actual data, and then ta-da, you have a really simple digital forest. And what we can do with digital forest is to run the simulation. And what I mean by running a simulation is to change a set of parameters. So let's say it's a very simple simulation. Our parameter is maintenance of what degrees of maintenance we humans want to give to the forest. Here in scenario 1, we're going to give good maintenance to the forest, and we want to see what would happen over 5 years. And we run the simulation, and then we can see how each tree would grow year by year. And what we can get from this is another set of data on how properties of each tree would change year by year. And of course, if you give different parameters, you will get different future scenario data. But these by themselves don't speak much to us. These are just numbers. So what we do to make sense of these data is we create certain metrics, like, for example, how much carbon the forest can sequester or how much water it can retain. And then by comparing these metrics, we kind of infer the conclusion that, in scenario 1, it's sequester most carbon, it retains the most water, so it might be the most desirable feature. But as one of my colleagues said, like most of what surrounds us, data is a human-made fiction, which means this whole process of building a digital twin, defining what a tree is, defining how it would behave, and deriving the certain metrics, and then inferring certain conclusion, it inevitably entails our human values and our perspectives. So a year ago, what I did with digital twin simulation is to question then how we might use data to sense something that flora and fauna cares from their perspectives. I don't have exact answers, but I want to share what I learned from it so that you can take away with you. First, to question how the model captures the reality. So coming back to this digital tree, if you think about it, how the tree is defined, it is largely, you can see that it's affected by how we see trees. We can see trees' crown, we can see trees' trunk. So we have a data about how big the crown is, how tall it is. But what if we can derive data about root, how big the root is, because with our human eyes, we cannot see what's in the underground. I can imagine what we can do with this. Maybe we can infer how a single tree is related to another tree via Mushroom's network. But then, by being able to sense this, we might be able to recognize a forest not as a sum of individual trees, but rather as maybe like collective of tree communities. And that's the kind of a different sense-making we need. Second is to reimagine the way we make sense of the data. So coming back to this data set that we created from the simple simulation, we created these metrics, carbon sequestration, water retained amount, and then it's kind of only shows a one dimension of the forest. So under this frame of, like, for example, seeing forest as a carbon sink, a death of a single tree can be interpreted as a decrease in carbon sequestration capacity. But in a broader perspective, a death of a tree can be also interpreted as more sunlight to younger trees because the shade area is decreasing. And also, you might think it helps soil, makes soil richer because as the tree decomposes, more organic matters are recycled. Or maybe even like the dead tree trunk becomes a new home to the wildlife. So maybe the forest become more wildlife suitable. So what we can do is generate this more different metrics, maybe measuring how active the life and death cycle of a forest is, or maybe how suitable this forest is for wildlife, or how rich the soil of the forest is. And this will give different sense of what kinds of future are more desirable. Lastly, create a relationship to complexity. I really like this example. I want to take a metaphor of a weather app. Weather app, they also collect data. They predict weather, but this weather app is really deeply ingrained in our everyday lives. Or at least for me, I check weather app every day, and then I decide, oh, shall I take my jacket with me or not? Shall I take umbrella or not? That informs my decision. So what if we can make this complexity of the forest relatable to you? So for example, when the weather app is telling you like how hot the temperature of the area you're in, maybe how about letting you know that, like, oh, you feel a little bit more cooler. You can sense that you're feeling a little bit cooler because of the trees around you, trees in your region provided the shade, so that's why you're feeling cold. So make it the complexity more relatable. I want to conclude this talk with a bit of a hopeful statement that climate change is indeed hard to sense, but we can try to rewild ourselves by reconnecting our senses to the planet. Thank you very much.